Question 3-106. Replace the parallel force system acting on the plate by a resultant force and specify its location on the XZ plane. So we have a force of 2 kilonewtons, 5 kilonewtons, and 3 kilonewtons applied at various points along the XZ plane on that plate. This is a parallel system, so the resultant force is just all of those forces acted together because they point in the same direction, which in this case is negative y. So we'll start by finding the resultant force. So there's my picture. Resultant force is just all the forces added together, like I said. So 2 plus 5 plus 3, our resultant force is 10 kilonewtons. So there's half the problem right there. Now what we have to do, we have to find its location where that resultant force acts on that plate. Yeah, I'll get it out of the glare for you so you can see. So for a parallel system, the overall moment is equal to the sum of the moment of each individual force, and moment is given by force times distance. So it's going to be a resultant force 10 times wherever it acts, and it's going to be equal to the 2, 5, and 3 times wherever they act. And we're going to need to do this twice, once in the x dimension, one in the z dimension, and we're going to get a point on that plate, and then we'll be done. So let's do x first. So we know that our resultant force multiplied by where it acts at the bottom of the screen there is equal to each individual moment. So F1 times x1 plus F2 times x2 plus F3 times x3, excuse me. Look at the picture and we get all of our values. We end up with 10 times x is equal to 2 times 1.5 plus 5 times 0.5 plus 3 times 1.5. Do all that algebra, we end up getting 10x is equal to 10, and our x value is 1 meter. So we found x, now we just have to find z. It's the same exact thing. Plug all the values in, you end up with 10z is equal to 2 times 2.5 plus 5 times 1.5 plus 3 times 0.5. Do all the algebra, you get 10z is equal to 14, and your z value is 1.4 meters. So the overall solution is 10 kilonewtons at 101.4 meters. And that's it.